Time to get rolling. Sorry we're a little bit late, but Pittsburgh traffic is Pittsburgh traffic, and so all you can do is adapt as best you can. Good morning, everybody. Welcome to CCAC's Allegheny campus. It's great to have you all here. So many different students from different school districts who suffered the trip in here on the school bus this morning. We appreciate you being here with us today. Today is dedicated to exploration of possibilities. So possibilities for the future of humanity, but also possibilities for your own futures. You're here to explore and see what the possibilities are for you. I'm Dr. Stephen Wells. I'm the Provost and Chief Academic Officer here. That means I'm in charge of all the credit programs. Before that, I was an English professor here for over 20 years. I've worked at CCAC for a very long time and seen thousands of students come through and take the first steps into the next chapters of their lives, and I love to watch that. And before that, I was one of them. So I went off to school, graduated from Mount Lebanon, went off to school down at Virginia Tech, figuring my future was clear in front of me, my pathway was clear. Well, yeah, I was wrong. I stayed there for about a year and a half, kind of hung on by my fingernails. My mother likes to say I kept up appearances, but when the report card came home with a C plus 3 Ds and an F, my dad said, nope, no more. So I enlisted in the Air Force. Bounced around in West Germany and then in South Carolina. The Soviet Union collapsed, and so that was no longer an option for me. I got out and worked construction jobs for a couple years, finally got laid off, and started back to school again at CCAC. I spent a couple years here, finished up my degrees over at Duquesne, and then came back here to teach. I was never positive where I would end up. Life opened doorways, and I stepped through them. So it's all about the possibilities. None of my experiences, though, was wasted. I learned from everything that I did, and you should learn from every moment of your lives as well. So what you want to remember is that it's about taking that first step. It's not about knowing exactly where you're going to end up. You just need a general direction and the courage to explore the possibilities, to step through those doors when they open for you. And you're going to see some great possibilities today that you might not have even imagined before. In case you don't know us, we have thousands of students who take advantage of CCAC's programs every year. We have 130 programs, including a whole bunch of training programs that'll take you right into the workforce, or transfer programs that'll let you finish up 2 years here, like I did, and then transfer to a 4-year college or university. We are incredibly affordable. 75% of our graduates leave without any debt, so you don't have to start off your life in debt. We have very reasonable prices that will help you through, and we have scholarships as well that'll help. But as you'll see today, accessibility and affordability don't mean that there are any limitations placed upon you. Our new Center for Innovation, Education, and Training that you're going to see today, at least the second floor of it, the cool floor with all the robots, is a 60,000 square foot facility, and it has the robotics that you'll see today. It has computer networking and cybersecurity, plus we've got a great culinary program, but that represents only a few of the programs that we offer. And remember, you don't have to wait to graduate from high school to take classes with us. We also have dual enrollment programs. So our entire undergraduate catalog is open to you. You can come down and take classes with us day, evening, whenever you can fit them in. We're glad you're here today. We've got some fun and interesting activities lined up for you. And now I'd like to introduce Dr. Justin Starr. Dr. Starr is CCAC's Endowed Professor of Advanced Technologies. His main job here is to design programs and certificates to quickly train students to step into exciting careers. But I like to think of him as the guy who plays with robots. Before he came to CCAC, Dr. Starr was Chief Technology Officer of a company that manufactured robots. He earned his PhD and master's degree in materials engineering from the University of Florida, his bachelor's degree in engineering science from University of Virginia, and where did he get his start? With a degree in business management from CCAC. Bless you. Thanks for your attention, and please welcome Dr. Starr to provide an overview of today's program.
All right, checks in the mail. That's a great introduction. Good morning, y'all. I'm so happy to see you. Like Dr. Wells said, my name's Justin Starr. I'm our endowed professor of advanced technology here at CCAC, and I'm thrilled that you are here for our second annual Space Day. So what is super cool about space, especially in Pittsburgh, is old people like to talk about when we were kids, so I'll just do it for a second. But when I was your age, if you wanted to do something in space, you really only had one option, well, two options. One option, go work for NASA in Florida, try to become an astronaut. Second option, go to Russia and become a cosmonaut, which was not appealing for so many reasons. But now in Pittsburgh, we have companies in the commercial space sector. The next lunar lander that's going to go to the moon is being made right here in Pittsburgh. Mission control for that lunar mission, you can walk to from CCAC's campus. So I hope all of you here are present today because you're interested in space, and today's program is designed to give you an idea of some of the opportunities and things that you can do without even leaving Pittsburgh to get involved in space. So a little quick rundown of the agenda, right? So I'm about to introduce our next speaker, who's from Pittsburgh's Moonshot Museum, who's gonna do a fun demo with some of the stuff on the table, and there's some sparks and explosions. It's amazing. Then we're going to have an astronaut who grew up in Pittsburgh, took classes at CCAC, speak to you guys about his experience. I'll introduce him in a second. And then you guys will do some tours where you'll get to see some of the new robots and exciting things we have in CCAC. So if you think space is in your future, you know what education can get you on that next step. Then y'all will get some box lunch and go home and have a great Thursday. So we're a little behind schedule, so I'm not going to talk anymore. Instead, I'm going to introduce our next presenter. He's a great friend of CCAC. He is the manager of learning and programs at the Moonshot Museum, which is attached to Astrobotic. Please give a round of applause for Mike Hennessy.
Thank you. Thanks, Mike. I'll take a moment for this. All right, good morning. How y'all doing today? Good. My name's Mike Hennessy. I work at the Moonshot Museum, which is just down the street from CCAC, and it's where you can see the next lunar lander under construction, designed, built, and will be flown from Mission Control Pittsburgh. And I thought today we would actually go on our own journey from the Earth to the moon. There we go. Like Justin said, we've got some sparks and explosions along the way. We've got some audience participation. And we're going to talk about all the different space careers that are available. I think whatever your passions or talents are, there's a way for you to plug into the space industry. And even more than that, something I could not say 10 or 15 years ago, there's a way to do that right here in Pittsburgh. So just quick show of hands, how many of you love to play video games? Because we are flying those robots right down the street to the moon. How many folks here love to cook or garden? We're going to need gardeners and farmers to help us learn to live on the moon. Anyone interested in going into medicine? There's amazing research happening in space right now that we can only do in Earth orbit that's improving our quality of life through medicine here on Earth. Do we have any writers? Okay, so we need lots of liberal arts majors in the space industry as well to write grants, to communicate the science that we're discovering to the general public. Anybody here like to argue? Excellent, okay. All right, we need space lawyers to set new policies. It's a whole wild new frontier out there, and we need to figure out how to share all the benefits of this amazing science and technology equitably with everyone here on Earth. So there are a lot of ways that might seem unexpected that you can plug in. We're gonna take a look though at where our lunar lander is headed next to get things started. So our mission today is gonna kick off with a journey to the south pole of the moon. There's a spaceship down the street under construction, and at the end of next year, it will be right about there. Heading to the moon's south pole, to a mountain called Mons Mouton. Mons is just Latin for mountain, Mount Mouton. And it's a nice flat plateau or mesa at the moon's south pole. It's about as tall as Denali in Alaska. It's about as wide as the entire state of Delaware. So this is a serious geological feature. And it's surrounded by craters that are dark and shadowy. They are super cold. These are some of the coldest spots in the entire solar system. We're talking 400 below 0 Fahrenheit because they never see sunlight. Ice from ancient comets was deposited billions of years ago, and it's still there now, and we could harvest that ice for water. Water to drink, water to grow food, water to break apart to make fuel for our rockets. So we want to go back to the south pole of the moon. What else do you notice in the sky there? Yeah, the Earth. Anything about the Earth in particular? It is blue? That's a good point. It's an ocean planet. What else? Yeah, it sort of looks like it's upside down. Because we're at the south pole of the moon, so we're seeing Antarctica at the top. You can see Africa and South America there. Very different perspective. This is Mount Mouton, and it's named for Melba Roy Mouton, one of the hidden figures of the Apollo era. How many of you have seen Hidden Figures before? It's a fantastic movie, right? Melba Roy Mouton was a human computer. That was her job during the early days where you needed a human to actually check the math and make sure the computers that could easily fill this room were doing their jobs correctly. And she had a huge role in calculating the trajectories for Apollo 11 to actually land on the moon. So this mountain was named last year in her honor. Please join me in giving her a round of applause. All right. So, I've been talking a lot about this spaceship. Would you like a sneak peek at it? Here it is. This is the clean room down the street. It's a company called Astrobotic. It's one of many companies, private companies, that NASA is working with in these public-private partnerships to get to the moon and do it affordably. The spaceship under construction is called Griffin, and you can see the aluminum frame there where the central thruster will be. This is a clean room environment where they're working. Who has a clean room at home, just out of curiosity? I gotta say, you're one of the most honest crowds I've ever had. But there's maybe about 1/10 the dust in the atmosphere there's here in this normal room. So we have folks who go to school at places like CCAC who get certified in HVAC, and their job is to constantly turn over the air and make sure it's filtered so we don't have any dust or debris that could block our circuits or our cameras or our scientific sensors from working. Just beyond in the back is Mission Control Pittsburgh. When the spaceship gets to the moon, there's a little more work to do on it. It's gonna look something like this when it lands on Mount Mouton. So you can see the solar panels around there. The solar panels are on the sides of the spacecraft because the sun is low on the horizon at the South Pole. We want to catch that sunlight for energy. It's going to be a tech demonstration to pave the way for future landers to take more science and technology to the moon. It will launch from NASA from Cape Canaveral, but the minute it leaves Earth's atmosphere, it'll be flown from right down the street. And then when it lands on the moon, we will be happy. This might be a stage photo. But this is Mission Control Pittsburgh, and this is where we've got folks hard at work who live right here in the region that will be flying. So I have a friend in Mission Control, and she said that it's kind of like being on a Zoom call where everyone's talking at once, and you're trying to pay attention to what's really important. Has anyone ever experienced that, where you're hearing a lot of different information, but you gotta focus? I thought we'd play a quick game to see what it's like to work in Mission Control. Some of you might be familiar with this game. You're gonna see some words on the screen. For instance, our first word is blue, but it is written in the color purple, pink, magenta. How you define it is just all part of the fun, right? You're gonna see a few more of these. Don't read the word. We're gonna focus on a different piece of information, and that's the color that you see. So just shout out the color, don't read the word. Let's give it a shot. Red, yellow, green. You're doing great, don't give up. I can see I made it too easy. Let's go twice as fast. I sense some hesitation. Are you ready? Yeah. Okay. Do you have the right stuff? Yeah. Here we go. Purple, red, yellow, green, red, blue, purple, green, yellow, green, yellow, blue, white, red, purple, blue, red, orange, yellow. I threw some designer pigments in there at the end for you. Give yourselves a round of applause. Yeah, nice job. We have heroes in space, right? For the past 25 years, we've had an outpost in the sky, right, on the International Space Station. We also have heroes who never leave the ground, who play a critical role in the space industry, and that includes folks who work in mission control. Here's one from the Apollo era. This is Margaret Hamilton. She's standing next to the code that she and her team wrote for the guidance computer on Apollo 11, the first moon landing. She coined the term software engineer. She was actually mocked for that term, if you can believe it, at the time. But she coined the term software engineer. A few minutes before Apollo 11 landed, there were a couple alarms that went off. And she had to make the call to continue with the mission because she knew that the computer, even back in 1969, could prioritize the commands and that these were low-level alarms and that they could actually continue. So because of her good job in coding, and focusing on information, just as you all did with our game just now, our Stroop effect. And because of her leadership in the moment, huddling everyone together, this is the woman who saved the first moon landing. So let's give her a round of applause. All right, before we move on, can we try one more mission control game together, just to test your focus? You're gonna see a few different folks on the screen tossing dodgeballs. I want you to just focus on the folks who are wearing white shirts. And we're gonna count together how many times one person wearing a white shirt throws the dodgeball to someone else wearing a white shirt. Everybody got that? You're gonna see some other folks playing their own game, but try not to focus on that. And again, that's key in mission control. You gotta both focus on what you need, but also be aware of all the peripheral information. So, all right, let's give it a shot. Here we go. 1. Okay, the number was 16? Yeah. I heard some interesting observations over here. Gorilla. How many of you saw a gorilla? Did anybody not see a gorilla? It's okay. You all expected it. Okay, who's seen the video before, just out of curiosity? Okay, who's never seen this before? Anything else unusual other than the gorilla before we play it back? Any other observations? Yes? So one of the folks wearing a black shirt left the game early? Who saw that? Who can confirm that? All right. Anything else unusual? Yeah. How they were moving. Okay. Anything else? Yeah. The curtain in the background changed colors. To what? What color did we go to? Red to yellow? You thought it was orange? Let's take a look again. All right. This time we don't have to count. Let's see if you caught all of the changes. Working as a team, if you put it together. So we have 3 folks wearing black shirts. Your gorilla is confirmed. Somebody left. And the curtain changed. Yeah, and they did a spin around there as well. So putting all of your observations together, you managed to catch all the information. Give yourselves a hand. Nice job. So I mentioned we're going to the south pole of the moon. That's where we want to land. And it's because we're looking for ice for water to sustain human life. Not just to go back for boot prints this time, although that was certainly impressive, but to go back now to stay and to build a permanent habitat on the moon. This is NASA's Lunar Reconnaissance Orbiter, or LRO. It's been one of our flagships in studying the moon and the South Pole. And we've imaged from orbit good indications of where we think ice is. And now we want to take the next step and send rovers from companies like the one down the street to get that truth on the ground, that Google Street level view of the moon, to know exactly where the ice is. And missions like the one we're building in Pittsburgh will help us pick the landing spot for the first woman on the moon in a couple years. It's really kind of fitting. It's Pittsburgh kind of going up and putting our parking chair on the moon and saying, we're going to come back in a couple years and send people, but we're placing the parking chair. So that's a UV map of the south pole of the moon. It's been colored different shades of blue, but it gives us a sense of these cold spots, these dark craters where there would be ice. And we're searching for that ice with robotic eyes that can see in ultraviolet. So I'll show you what I mean. Brought along a moon. Yeah. So a representation of the moon. You can see a lot of American flags here where the Apollo program went on the equator, but we want to go here to the South Pole. This is a new region for us to go to. And I brought a UV lamp with me to show you why. So if I shine this UV light here, you can see just a little bit of a glow on the equator. If I come down to the South Pole, what do you notice? Yeah, lots of ice there. Imagine this is a faraway star. It's not the sun. Sunlight's not shining into those craters. This is light from other solar systems shining into these craters, but we can only spot it with robotic eyes. We can actually see in UV. So we are on a treasure hunt for ice, and we're seeing with robots by the light of faraway stars. And that's just one of the techniques that we're using to find ice on the moon. So we can find it on the South Pole. That's where most of it is. Where else do you think we should be looking? Probably the North Pole. And you're right, yeah. This is highlighter. This may have started out as an accurate map and gotten a little more representational as I kept painting. But yeah, that's basically where the ice is on the South Pole of the moon. Let's think of it another way. This is tonic water. Has anyone ever had this like fizzy, bubbly tonic water? All right, if I shine a UV light on it, and I didn't do anything to this. This came straight from the grocery store. But we've excited the molecules in here, and they're giving off blue light. They're being excited with ultraviolet energy and giving off blue light. Let's try that again. I'm hoping you're just as astonished the second time. Ready? Yes, we're awesome. Can I get an ooh just from this side? Ready? Okay, now it's on you to do the ah. One more time, we're going to see who's more excited about this. All right. We're going to head a couple other places now. See some friends who just joined us in the back. Welcome, my name is Mike. I'm from the Moonshot Museum down the street. We're astrobotics building lunar landers. And we're taking a look at different places on the moon that we're exploring. I thought we'd actually step back to the future for a moment to the Sea of Tranquility, where Neil Armstrong first took his small steps on the moon. You can see Buzz Aldrin here saluting the American flag. And Pittsburgh is even in that photo right now, too. Is there any wind on the moon? No, right? So a technician who worked for NASA, his name was Jack Kinsler, grew up on Mount Washington. He figured out basically how to make the flag look like it was flying with a wire mesh and essentially a telescoping rod at the top. Got the idea by watching his mom hang curtains one day and thought that's what we really need on the back of the flag. So again, Pittsburgh was kind of baked into the very first moon landing in so many different ways, from Westinghouse cameras to even the American flag. But we might go back to the same spot because it turns out the Sea of Tranquility is even more interesting than we thought back in the 60s. Here we've got a false color map that shows all the minerals and metals that we've been discovering on the moon. Can you see the dark blue blotch at the bottom there? That's the Sea of Tranquility. It turns out there's a lot of titanium there. It'd be a great metal to work with as we consider building electronics and robotics, actually living off the land on the moon. You can see a lot of pink there. That represents aluminum. You've probably got something aluminum at home, right? Foil, computers, bicycles. It's the most common metal in the moon's crust as well, any of those brighter spots on the moon. We've got some green and orange there. That's different volcanic rocks. And I brought two different metals that you'll find on the moon today. These won't seem too exotic because you can find them here on Earth. And they both have a big part in Pittsburgh's story as well. So I've got aluminum. And what do I have here? Yeah, it's just iron. It's just a rusty iron sphere, so it's iron oxide. We're going to bring the aluminum and iron together. Now imagine I was an astronaut on the moon, maybe a decade or two from now, and I found aluminum and iron. It's not going to rust. There's no air there to make it rust, but there's plenty of oxygen in that lunar soil too. So I've got aluminum, I've got iron, I've got oxygen. I can bring them together and make some sparks. This is the sparky portion of the show. First really use that. So I'm going to bring them together. It's going to be a little loud. If you want to cover your ears, feel free to do that. And we'll get a countdown, and we'll have the aluminum react with the iron oxide. I'm attempting to weld the aluminum onto the iron sphere. So can you all give me a countdown from 3, 2, 1. And we're going to do that just once and put it away. What do you say? All right, should we try it again? Yes. Okay, all right. Can you give me another countdown in 3, 2, 1. Again? Yeah. All right. And the crowd turned. I've got a boo. How quickly they turn. All right, let's try it again. I might be off the stage soon. Should I quit while I was ahead? So imagine being on the moon. You don't want to have a lot of liquid fuel that you have to take up to start a fire, but there are innovative ways you could actually do microscale reactions, maybe weld metals together, heat them up and bend them, make your own tools, again, live off the land. And it's going to take a lot of technical skills in the trades to do that as we build habitats. Here's an artist's conception of a home on the moon that we would actually 3D print from lunar soil, from regolith, modular structures that we could build. Again, if we're trying to haul everything from Earth, it's going to cost so much money because we're trying to escape the force of gravity, right? Building huge rockets to take everything with us. So if we can live off the land, it would be more efficient, whether we're using robots to build domes, to build these sort of SpongeBob things. But again, they're modular. You can see all the different bricks there. And just one thought of how we could actually live on the surface of the moon. All right, we're going to take just a couple minutes here, I think, to wrap up. We're going to go a couple more places very quickly, because I've talked a lot about robotic missions, and that's really paving the way in the next few years for the first woman to land on the moon. NASA's Artemis program will be sending the first woman, the first person of color, and the first non-American. There will be a Canadian joining the crew as well. There'll be a crew of 4 that will be flying around the moon next year, and then Artemis 3 will land humans on the moon's south pole. I'll show you some video of Artemis 1, which launched a couple years ago at Cape Canaveral. So this was the test. It was uncrewed, but the next one will be.
4-stage engine start. 3, 2, 1. And liftoff of Artemis 1. We rise together, back to the moon and beyond.
So this powerful rocket will be carrying people and our hopes and dreams on a 3-day journey to the moon, and really pave the way for us to create a permanent presence in space. Our goal, in addition to setting up a base at the south pole of the moon, is to actually have an orbiting space station. So today we have the International Space Station that orbits the Earth. Our aspiration for the future is to have a lunar gateway, a small space station that's in orbit of the moon, that again could be continuously inhabited, that we could have people from countries around the world working together in peace and friendship, and doing some amazing science together. So you could travel to the moon, maybe fly down to the South Pole, do some geology, come back for lunch, but you'd be living in orbit, maybe not just for days, but for weeks or months at a time. Who would like to take that sort of trip to the moon someday? Yeah, that's the dream, right? Expanding access, I think, for more science, more art, more innovation to happen on the moon. And it's a dream that we've already been building towards on the International Space Station for the past 25 years. Here's a quick video of the next speaker, working with water in microgravity. And of course, with microgravity, right, the water's not being pulled down. But you can see how just everyday tasks, like working with water, can be difficult and challenging, and you have to get a little more innovative. Who would like to take a trip to microgravity to the space station? So the moon, maybe 1/6 the gravity of Earth, but in orbit of the moon or Earth, you're really in a state of microgravity. Another Pittsburgh astronaut, Woody Hoberg here, doing a somersault, was on the space station just last year. And you see, you can have a lot of fun. There's a lot of challenges, though, so if anyone's interested in going into medicine, if we have more people living long-term off-planet, we need to figure out how to keep our bones and muscles strong in microgravity. There's a lot of opportunity, though, as well. Here you can see insulin crystals growing on Earth. The ones in microgravity grow bigger. It makes them easier to study and has led to treatments for diabetes. Today in orbit, we're working on tissue chips. We're working on essentially sending tissues to space and trying to grow them. So maybe we could have solutions for transplant patients in the future, actually growing organs or tissues in outer space. Thought I'd bring a volunteer on stage, though, to experience, you were first, so, whoa, that was awesome. Come on down, let's give a round of applause to our volunteer. There was no hesitation at all. We're gonna play a game. We just talked about some of the benefits of living in microgravity, doing medical research, using space in a way that we just can't on Earth. But we're gonna have some fun with that too. What's your name?
Nevaeh.
Nevaeh, I'm Mike, nice to meet you.
Nice to meet you.
All right, so if we were actually up in space, if you were doing those somersaults or trying to take a drink of water, when you first get to space, come on out here with me. You might notice, right, there's that lack of gravity, you're floating around. If anybody's ever felt dizzy, if the fluid in your inner ears is spinning around a little bit, you could have that in your cochlea because it's microgravity and that could be sending your ears confusing signals. Not going to do that today, but we are going to do a little training exercise which is all about not trusting your senses, right? Going to space and having to relearn how to do simple things. So instead of fooling your ears, we're going to fool your eyes. We've got some goggles here. They're going to shift your vision. You're going to look great, actually.
God.
No, you're good. You're doing fantastic. I think Nevaeh looks great. Let's give a round of applause. So they're shifting your vision, so it might be a little tougher to see, but we're going to try something real simple. Just take the ball from my hand. Hey, there you go. Yep. And just maybe walk toward me and put the ball back in my hand. Nice. All right, let's give a round of applause. That was really good. All right, I'm going to hold it out again. I'm going to take the ball from you. It's a challenge, right? So, and maybe I'll back up a little bit. Just gently toss it to me. We'll see if I can catch it. All right, that was actually really, really good. Take it one more time. There you go. And one last time. Go ahead and toss it toward me. All right, let's give a round of applause. Nicely done. But you know what? I can see you were getting even more confident with it on your second toss. And it'd be tough when you come back to Earth, right? Too. You have to adapt to being in regular gravity. So we'll make sure that doesn't happen. We'll have you actually walk off this way. Let's give a round of applause. Nice job. So I have just a couple of minutes left, and I want to take a moment to look back at our home planet. And then we're going to maybe do one last messy demonstration, and we'll wrap up. But the last place I want to take you today is to Anders Earthrise Crater. And I want to take you back to December 24th, 1968. This is a CGI recreation of the view that the first astronauts to circle the moon would have seen as they rounded the far side in Apollo 8 and looked back at our home planet. And one of the astronauts, for whom the crater below is mentioned, would take that photo of Earthrise, one of the most famous photos, right? The astronaut Bill Anders famously said, "We went all the way to the moon, and the most important thing is we discovered the Earth." And that really galvanized the environmental movement. So even as we have lots of jobs in space that are looking for taking us to the moon and Mars, do we have anybody interested in conservation or environmental science? Because it is from our eyes in the sky that we get invaluable data that we can only get from that space perspective, looking back at our home planet to learn more about it. So here's just some quick examples of work happening on the space station. This is JEDI, probably one of my favorite acronyms. But it's all about using lasers from space to measure the height and density of forest canopies around the world so that we have good data on a global scale to manage our forests. Another project called EMIT is all about essentially scanning in thermal imaging with infrared. And it helps us find and detect open methane leaks in wells. So we have global data so that we can monitor climate change threats and get great data from space. So lots of different ways, I think, unconventional ways that you can get plugged into the space industry. I'm going to jump ahead for a moment just to take us to our finale. We're going to go back to the south pole of the moon, this time to the geographic south pole of the moon, Shackleton crater, named for the explorer Ernest Shackleton, who went to Antarctica, and to one of those permanently shadowed craters, and just give you a sneak peek at some things that are coming up next. So next fall, Pittsburgh will be landing on the moon with the Griffin lander, and we're hoping to deploy one or more cube rovers. These are small rovers about the size of a toaster that will set up a power grid, so a mobile power grid of solar panels so that you have energy on the go. Here's one actually being tested in the lab, again, down the street. You can see it working on simulated lunar soil. And it could carry anything you want, a scientific payload, it could carry a work of art, it could carry a tech demonstration, but the idea of providing access to countries and colleges and students around the world to actually do science on the moon. It's an exciting time that more people are going to have access to do work off planet. And then finally, thinking of the moon is really just the beginning. The moon is really our test bed. It's our neighbor next door in space, and it's how we're going to go off to Mars. If we find fuel sources on the moon, for instance, carbon dioxide, dry ice might be one of them at the South Pole. We could blast off the moon much easier because of that lower gravity and use it as a gas station to get to Mars. So I thought for our last demonstration today, we'd have some fun with carbon dioxide. This is my carbon dioxide. So I've got some Diet Coke. It's CO2 that gives it its fizz. And I'm going to add something to it to release that carbon dioxide. What do you think? Mentos. You, my friend, are in luck. We have Mentos today. I'm going to add some Mentos to this. Before I do, take a look at the Mentos under a microscope. They look kind of like the moon, right? So these Mentos have lots of, we call them nucleation sites. Lots of nooks and crannies, lots of craters where the CO2 can collect. And when that happens, it provides an escape hatch for bubbles of CO2 to form. And what happens next? Exactly. So let's set one of these off. Imagine you're on the moon, though, if you were living at the South Pole. Again, we know there's ice on the moon. The temperature suggests that dry ice could be there. We don't know that yet, but our hope is that might be one of the potential fuel sources that we could use to power things on the moon. All right, so I've got Diet Coke in here. I've got 5 Mentos. Well, it could be anywhere from 1 to 5. How many should we use? 5. That was unanimous, okay? All right, I'm going to add this on. Should I put my safety goggles on first? Yes. I was really hoping there wouldn't be any debate on that. All right, this is very delicate work here. I'm going to get this attached, and then we will have a countdown. All together from 3, 2, 1. There we go. We are off. Can we have a round of applause for our Diet Coke and Mentos today? All right. I want to leave you just with an artist's vision of what life might be like at the South Pole on the moon. This is where we're heading. We're going from a one-world to a two-world species. But for every one person who might live on the moon, there are going to be thousands others who are so important in the space industry living right here in Pittsburgh. And I hope that's some of you someday, whatever your passions are. And I'd also invite you to come see me at Moonshot Museum sometime and learn more about how you might plug into space. Whether you get a job in space or just make space part of your life as a citizen to know more about what's happening there. So you've been a great audience, though. Give yourselves a round of applause. Thank you very much. Definitely come see us at Moonshot Museum sometime if you're more interested in talking about space careers, and I'll turn things back over to Dr. Justin Starr.
Awesome as always, thank you. Man, he's the best, right? Mike's awesome. That was such a cool demo. How many of you guys would like to see more of what Moonshot has to offer? Yeah, all these hands up. Great news. So after today's program, you guys should talk to your teachers because your teachers will be receiving an email that includes free admission for everyone here to go to Moonshot Museum. So I know y'all have a tight schedule today. You got to get back to school, get on the bus, go home. But you'll have that free admission if you ever want to go to Moonshot with your families, check it out, spend some time with Mike. They have some amazing activities there. And the Moonshot Museum is, I think, the only museum in the world where there's a window into people making a lunar lander. So when you visit the Moonshot Museum, not only will you see cool stuff, but you can look through the window and you can see the guys working on the thing that's going to go to, like the real thing that they're about to send. Now, you can't see it when they send it, but now is a great time to go and actually see that in progress. So we're really excited for that, guys. But I'm not the next thing on the agenda. The next person I want to introduce on the agenda is also named Mike. He is a Pittsburgh native and NASA astronaut, Mike Fincke. Mike has an amazing background, like so many people who call Pittsburgh home do, right? Mike grew up in Emsworth. He went to Swickley Academy. He followed that on with further education at MIT and Stanford. But probably the most important thing is he took a class at CCAC while he was still living here, and he launched his first model rocket right here on CCAC's campus. So if you guys are wondering where the journey to space starts, it really could start here. That's true. His career in space is incredible. He was on 3 missions. He's logged more than a year in space. 300, just short of 382 days. I think it's 381.6 days in space. He's done 9 spacewalks for more than 48 hours. So 2 whole days in space, and he's a Pittsburgh native son. So we're so lucky that he came to visit us today and spend some time here at CCAC sharing what he did in space with all of you. So without further ado, it's my pleasure to introduce our next speaker, astronaut Mike Fincke.
Thank you. I'll say while I'm setting up here that I've known Mike Hennessy, your previous speaker with all the cool demos for 14 or 15 years. Man, you're getting better, man. You're awesome. So it's going to be really hard to follow that guy. I don't have any Mentos with me, but I do have a presentation that I'd like to share with you today. And see if I followed my training on the microphone. I'll get that in a second. NASA logins. And so I am thrilled to be here. It's good to be back home. And I actually got a picture of me here at CCAC with my first model rocket. And there's a story to be told here, and I'll share it with you. But one of the really cool things that I liked from Mike's presentation. So I know a little bit about my audience here, but have any of you ever played this thing called Minecraft? Anybody know Minecraft? What? You have Minecraft in Pittsburgh too? So what I like about Minecraft is that you take natural resources and you build stuff. Now, I like creative mode. I'm not really into beating up what are those guys that explode on you? Yeah, creepers. Yeah, that part of the game isn't as much fun for me, but I really like the ideas of building an underwater castle or something up in the sky. I mean, you can the sky is literally the limit. Whoa, look at that. Let's see if we can get our clicker to work. This is not as fun as Mentos, but we're working on it. All right, and unmuting. All right, can you hear me now? Excellent. All right, so so I like Minecraft because it shows the possibilities, and Mike was hitting on it of us going like Minecraft on the moon. You take the local resources, the dirt on the moon's called regolith, but it's full of aluminum, and titanium, and there's some water stuff in there, and you can make stuff out of it. And that's what's really neat. I mean, this is a city where we've made things. All the bridges across this country were built by the steel that was made here first. And then we don't make steel so much anymore, right? So what do? Well, this city has a lot of talent, and we need you at NASA. And like Dr. Starr mentioned, your path could start here, like mine kind of did at CCAC, Community College, Allegheny County. Thanks for having me here today. And if I could go to space, you guys can too. But it's not always, clicker, come on, man. All right, we're gonna go manual. See, that's what happens with automation. Sometimes you gotta go manual. All right, how about this? Nah, all right, we're gonna go this way. All right, that's not working either. I start at the beginning. You saw the sneak peek of CCAC back in the 1970s, not the 1870s, 1970s. All right. And Houston, we don't have a problem. All right, this is Pittsburgh. I took a picture of my hometown from outer space, going around I was on the International Space Station. I was a kid watching people walk on the moon, and I'm probably never going to walk on the moon, but I knew that's what I wanted to do, and I got to be an astronaut. And so when you're up there in space, and some of you actually might be in space someday, we're working on really hard to open up space for a lot more people. But like Mike said, if you not go into space, you can help the people that are there and build stuff that goes to space, and that's really cool. So, but this is Pittsburgh, and we are here right now. You can see the Allegheny River, the Monongahela River. Most people around the country cannot say Monongahela for the life of them, and the Ohio River. And I actually grew up somewhere like around here. Not that I will admit to ever been growing up. But that's what Pittsburgh looks like from the International Space Station. I'll tell you more about the space station, but just remember, it goes 17,500 miles an hour. We go around planet Earth. That's our home planet, in case you didn't know, and go around planet Earth and every 90 minutes. So to get a picture of your hometown, you got to go click, and then it's gone. So so I was really glad to take this picture back in 2009. All right, next picture. All right, here we are at CCAC campus. I drove by this place this morning. I think there's like a Dunkin' Donuts and a parking lot. But back in the when was this? 1970s, not 1870s, 1970s. I took a summer class. I think some of you sometimes get a chance to go to a summer class. I saved my money from my paper route, took a PAT bus all the way to Buell Planetarium, back when we had a Buell Planetarium. And I took a class on rockets and airplanes because I was a little kid, and although you're right there, and I was very glad to, I was really wanted to learn about rockets and airplanes, and I figured somebody downtown here, north side, would teach me about it. And sure enough, the first model rocket they gave was a Russian Vostok on the Estes company. Now, I will explain that is a false advertising. It's not Russian at that time, it was Soviet Union. Soviet Union doesn't exist anymore. So now the version of Vostok is called Soyuz, and it is Russian. But back then, it was really Soviet Vostok. But they gave it to us, and I didn't know better to build a Soviet rocket. They just said, hey, build this. So I built it, and it actually flew. You can see it not blowing up here. And that's even high resolution. And that was me right here at CCAC. One of my first trips to CCAC was launching a rocket, because when I was growing up, I did not think I was nobody, and especially Pittsburgh kids, are going to go launch with the Soviet Union. I mean, those were the bad guys. There's a Cold War. They were going to blow us up. It was a scary time. I don't know if it's less scary now, but it's different now. But once the Soviet Union dissolved, surprise, spoiler alert, 1991, NASA decided to start working with the former Soviet republics, including Russia, and we said, hey, you guys have a space program, we have a space program, why don't we be like really good humans and work together? And sure enough, because when I was in college, they said, you got to learn a foreign language. I'm from Pittsburgh. We don't speak foreign languages. I mean, we got Pittsburghese and English, I guess, maybe. And they said, nope, you have to learn a foreign language. I said, all right, what other country has a space program? They said, Soviet Union. I said, okay, I'll learn Russian. Like, how tough could it be? Но потому что я говорю по-русски без проблем, я мог летел в космос через Союз. So it turns out that I could learn to speak Russian pretty quickly. I was an exchange student in the Soviet Union, and that's why NASA picked me up. They didn't pick me up because I had an aerospace engineering degree, a planetary science degree. They didn't pick me up because I was so tall and handsome. Well, no, never mind. But they did pick me up because I could speak Russian and oh, wrong way. There I was, my very first rocket, very first trip to space, the first time that my dream came true was launching off of a Russian Soyuz off of Yuri Gagarin's launch pad. Yuri Gagarin was the first human to fly in space, and he launched from his launch pad one time, and this kid from Pittsburgh got to launch off of Yuri Gagarin's launch pad twice. Eat that, Yuri. No, you can't say that. No, but what some of the messages there is that the world is changing. It's going to change. The world that we know today will be different 20, 30 years from now. And how can you position yourself to take advantage of all the cool things that are going to be happening? So why do we do this, right? So why do we have a space program? There's all kinds of people across the planet that are starving. We have wars and things like that. So why should we spend any money on a space program? Well, and those are good questions. Those are philosophical questions, and we all have to think about it in our own hearts. But I'll give you some things to think about, perhaps. I will say that once we know more things about our universe, we make life better here on planet Earth. And that's a good thing, right? Nowadays, I would say my mother, actually, she grew up 2 blocks away from here on Western Avenue. And what they had in the 1940s is different than what I had growing up in the 1970s and 1980s. And her mother remembers when electricity came to their small township in Ohio. Can you imagine growing up without electricity? Well, so most of you would agree that it's better to have electricity than not. And I'll say that we had a hurricane go through Houston, where I live now. Not the one yesterday, but the one from a couple months ago. And my house was without electricity for all of 26 hours. And it was a pain because it was so hot and humid. Air conditioning didn't work. It was so hard for us, right? Can you imagine going through your whole life without electricity? Well, why do we have electricity? Well, it's because in the 1700s, when you were bored at night because there wasn't anything else to do, you would have parlor parties and parlor games, and you would do fun things like shock your friends. I think guys like Mike Hennessy made a lot of money back in the 1700s with all kinds of demonstrations of this thing, static electricity, and you could actually put static electricity in a bottle, lightning in a bottle, right? There's even a cool song about that. But lightning in a bottle, right? So that was fun. No use for it except to shock your friends, make enemies, all those kind of things. But we actually thought about it. Humans looked into the universe, tried to figure out what's going on with that lightning in a bottle. What's going on with lightning being electricity? What's going on with magnetism? Wait, magnetism and electricity are related? And so James Maxwell made these Maxwell equations. They worked out beautifully. And then Thomas Edison said, so what? What can we do with it? Well, he made the first practical light bulb and the General Electric Company, and started to electrify America. And now in the 2000s, we have LED bulbs, and it's a completely different way to light things up. But we understand electricity. By understanding the universe, by understanding electricity, we have conquered the night. And this is what you can see from the International Space Station. Flying over the dark side of the planet, you can see the big white flashes. Those are lightning from clouds. But all this orange kind of things, those are cities. Those are people that can stay up all night playing Minecraft or, doing homework. So we have conquered the night. So we've made life better because we understand the universe around us. My friend Mike Hennessy mentioned we need all kinds of people in the space program. including artists, and any of you have artistic talent, we need your inspiration. This was a painting in 1968 for a movie called 2001. And because that was the big future in 1968, apparently. I think we're like beyond 2001, farther, because it's 2024 than 1968 was. But anyway, so 2001, there was a really cool movie. It's called The Space Odyssey, and they went to Jupiter. But in the movie, they showed people walking or launching from the planet, going up and down to planet Earth in a space shuttle to a space station. And we said, oh, that's really cool. That's so inspirational from 1968. And then we said, wait. At NASA, we said, we're a bunch of engineers. We make stuff. We build stuff. We're like crafters. Let's make one of those. And they said, what? Make what? It's like, well, let's make a space shuttle. And then with the space shuttle, we'll make a space station. And so we did. And I'd like to share the space station with you, because that's where I joined
NASA in 1996. And my first job was to go over to Russia, because I could talk, and help the Russians with their modules, the space station. And then we started putting the space station together, and then I got to live and work aboard the space station, and I was commander, and if I'm lucky, I'm going again next year. So, this is NASA, brought to you by the letters. Can you imagine leaving your homeland in the winter, launching on a Soyuz or a Dragon? That's our space station. So 15 countries across planet Earth working together to be constructive and not destructive. And this is what we made. Myself and my colleagues aboard Space Shuttle Endeavour took this video. I took a lot of photos and video as we flew around the International Space Station. We sped it up, but that's humanity's outpost to the stars. Now, there's another space station up there built by the People's Republic of China. So there are 2 space stations now, and we're working on making a lot more. But this is the International Space Station of us working together and doing things together. Now, I don't have any cool demonstrations like Mike did. But I do have how fun it is to actually be in space. I would like to give a disclaimer right now, is that you will see people actually having fun at their job. Now, in real life, aboard the International Space Station, we do work hard. We're not always messing around and playing around, but I will share with you that there's a lot of hard work, but there's also a lot of fun. So first off, aboard the space shuttle, you can play with your food, and you can play Hungry Hippos. Those guys are in their 40s, and they're just playing like kids. You can see water, the spherical properties of water. You can be a great dancer in space. And you can learn without the gravity, more about the laws of physics, conservation angular momentum, or the law of bonk. And you can fly. Flying in space is so much fun. It never gets old. There's my friend Greg Shamatoff. We made an aquarium together. It's just a big ball of water. Those were not real fish. Those were those Swedish gummy fish. And then you can do the Iron Man maneuver. I invented the Iron Man maneuver. Now, you saw this video a little bit earlier. Mike showed that. Thank you, Mike. And it says, I love Carnegie Science Center. Now everybody's doing the Iron Man maneuver that I invented, but if you ever get to the space station, you should try it out. There's just one module that's above us, and you have to push off with your toes. Senator Mark Kelly, now a senator, he did not push off with his toes, and we had to teach him. This is the inside of Space Station. I showed you the outside, but this is what it looks on the inside. And, oh, she has a lot of hair. We're flying around American Laboratory. There's my friend Dimitri from Russia. That's Mark Kelly, no hair. Paolo from Italy. And you can see there's a lot of room on the inside of Space Station. There I am getting ready with my friend Drew Feustel for getting ready for a spacewalk. We're now in the Russian part of Space Station. You can see it has a different look and feel, a different aesthetic, more Soviet style, but it's all connected, and we all work together in space, no borders. And that's one end of Space Station to another. And there's a lot of room inside, and I think right now we have like 11 or 12 people inside the space station, so it's getting a little bit crowded. So that's currently what we have is the International Space Station, and you saw a little bit of what Mike Hennessy showed of us getting ready to go to the moon. The way to get to Space Station right now, we can fly with the Russians on the Soyuz. And that is a lot of fun. My friend Don Pettit launched yesterday aboard the Soyuz and made it to the space station. We have SpaceX, the SpaceX Dragon. That's kind of new. We've had 8 crews go up. We also, SpaceX being a private company, they also launched a different crew, not NASA at all, just 2 or 3 days ago, and they are orbiting on a very high orbit, and they just did a spacewalk, the first commercial spacewalk this morning. So this is all very topical, very present. And then also these 2 friends of mine stranded in space. They have no food. They're all going to no, none of that. They did not come back down in the Starliner. Starliner landed, I don't know, a week ago. I was there in the desert, and it landed fine. We chose not to put Butch and Sonny inside, so they're still aboard the space station. But Starliner program is going to be another way, and right now I am going to be the pilot for the second Starliner to go up once we figure out what went wrong, and we'll go up to, I'll get to go a chance to go to the space station again. We have to feed and clothe our astronauts. We don't need any hungry, naked people flying around in space. That's not fun. So we have in all of our science experiments. So we actually have cargo ships that go to space that we send up. We have a cargo version of Dragon, a Cygnus from the orbital, now that's in Northrop Grumman. And then Sierra Space is going to have a uncrewed space plane launching sometime next year. I believe we saw that already. All right, and of course, we at NASA, we do other things too. We go explore the solar system with robotic probes, and one of our biggest new things is to go to the moon again, like you heard from in the previous speaker. And we're gonna still keep the ISS around for a while. We're gonna make some more space stations in low Earth orbit, and there's gonna be a lot of money and a lot of really cool action and adventure for that. And NASA's gonna be focusing on the moon. With commercial lunar landers such as Astrobotic right down the street. And then we're all keeping our eyes on Mars. So we talked a little bit earlier about the Artemis program, where the next people to go to the moon since 1972 are going to go. They're going to land in the South Pole, which we got to see. I want to steal some of your videos, Mike. Those were awesome. We're going in an Orion spacecraft. That's going to launch aboard the Space Launch System. It's the only part in here that doesn't have like a really cool name. Hello, my name is SLS. I'm a very boring big rocket. Anyway, but every time we give it a name at NASA, big rockets, then they get canceled by Congress. So we're going under the radar with SLS. All right, we have a human landing system. We saw the SpaceX version in Mike's slides to land, and these human landers will go up and down to the space station around the moon called Gateway. This is a SLS rocket. It's like a space shuttle and a Saturn V combo. Take the solid rocket boosters and kind of the external tank, some of the engines from the space shuttle, but you put the spacecraft on top like we did with the Saturn V. And we're going to be sending my friends to the moon in the next year or so. You already saw Mike's video was better, so we're going to skip that one. We talked about this a little bit, where my journey to space really started right here. So I'm really excited to be here with you today. but also all the cool adventures when you're on the way to becoming an astronaut. And I think that's a cool thing. This is my story. You guys are going to have your own stories, and I'll give you a few ideas along the way of what can help you achieve what your dreams are. But along the way, I got to live in caves, literally underground for a couple weeks, underwater for a couple weeks. I get to fly these really cool airplanes. That's Mark Kelly and myself. I have a green helmet flying a T-38. I was on an Arthur episode. There's me in my green helmet. And got to meet different people. I made President Obama laugh. Got to be on a Star Trek episode. And my wife's family's from India, so I got to go halfway around the world and be honored as a space hero, a son-in-law. And also I was Buzz Lightyear's commander aboard the space station, so we had a victory parade at Disney. Free admission to Disney, yo. It's awesome. But it's about the places where you're gonna go. And that's what the Space Day today is about, is for you to think. I know it's not easy being in school right now, thinking about what you want to be when you grow up. I know I'm still trying to figure out what I want to be when I grow up. But we're going to give you some things to think about today at CCAC, right? Mike hit on some of the things, really the message for today, as did Dr. Starr, is that whatever it is you want to be, you're going to have opportunities, especially here in Pittsburgh. There's great educational opportunities. There's all kinds of things where you can be and grow. So whatever you want to be, you should go for it, because there's people around here that want you to have that same feeling of your dream coming true. For me, it was sitting on that rocket. You saw my picture. Wasn't the Estes Vostok. It was a lot bigger. It was the Russian Soyuz. And that was when my dreams came true. We want you to have your parents, your families, your teachers, and folks here at CCAC, folks at the Moonshot Museum wanting you to be successful. So what's it be to successful, right? What do you want to do? Well, there's all kinds of things. Some of you might want to have my job. You can have it. It's a great job. But there's other jobs out there too. And if you want to make things, you want to build things, you want to make a difference on planet Earth, there's going to be opportunities here in Pittsburgh. There's going to be opportunities abroad. But I will tell you, at NASA, we need a lot of help. We're doing all these really cool things, going to the moon and going to Mars, but we don't have enough people to help us. We don't have enough people that know how to put stuff together. We don't know enough people to code or to build things or make things. We don't have enough HVAC specialists and things like that to help us to build the pieces to go to the moon and Mars. We need your help, and that's one of the reasons why I'm here. CCAC has some great opportunities. The other colleges around here do, and some of you I think are from up near the Pymatuming area. You don't have to come to Pittsburgh. It's a great place, but you have other options too, in Ohio and other areas too. So there's a lot of opportunities here. What do you want to do with it, right? So it's not about me, what I did, because I had some really cool times. I have some more cool times in my future, but what are the places you're going to go? Think about it, and today you're going to see some opportunities. So maybe that'll give you some food for thought. So this is my free advice to all of you. This is the 5 things that have helped me to get to my dreams come true. And maybe some of these things will help you to get your goals and aspirations. And if it could happen to me, it could happen to you. So first off, we're all human beings. We need to be nice to each other. So be good, study hard. Be nice to each other, study hard. The more things you know, the more opportunity you have. I got picked to be an astronaut because I could speak Russian and Japanese, and a few others too, but I didn't know that growing up. I just studied in college, right? Dream big. That's one thing that we sometimes forget about. We live in the world's greatest country, and where big dreams do come true. So really, dream big. Don't sell yourself short. Never give up. Along the way, I had some bad days. I'll tell you, if you ask me about it during the question and answer session, which is coming up in about 2 minutes, about the worst day in my life, and I never thought I'd be an astronaut, and yet I was wrong. So never give up. And then finally, I just added this in the last year, because I'm not good at asking for help. I think I can do everything, but really, sometimes I need to ask my friends for help. You should too. And when your friends ask for help, you should give help. I was always good at giving help, but asking for help. If you can ask for and give help, you're going to be a great team member, and you're going to be very successful, and you're going to live a richer life. So This is a picture, we talked about the inspiration of that picture of space, that space station and that space shuttle for the movie 2001. Here's a picture from 1970 with John Young. He's saluting. There's a Pittsburgh-inspired flag right there, and he's saluting all of us. And I hope to see some of you guys on the moon someday. And I know if not, you'll be the people helping us get to the moon. And those opportunities are there for you. So ladies and gentlemen, welcome to CCAC Space Day 2024. There's going to be some ideas for you to think about what you might want to do, but there's room for you in the space program, and we need all the help we can get, especially Pittsburgh help. It's the best. All right, thank you. That's it for my formal presentation. Thank you very much. And we have about 15 minutes for questions. Now, nobody has to ask any questions because I'm pretty sure I explained everything so perfectly so there cannot be possibly any questions. So we can all have recess, or is there some questions? There's some questions. All right, I'll do better next time. Are we walking around with microphones? If not, that's okay. In the red shirt back there, stand up, and if you don't mind, please, and thank you. I'm sorry? Is it important to have a schedule in space? Is that the question? Yeah, so that's what I really liked about living for over a year of my life in the International Space Station, because they told me what to do and I just did it and nobody got hurt. So it's important to have a schedule. It's important to be organized. It's important to have a schedule for getting training. So we actually have whole teams of schedulers that manage our lives and tell us where to go and where to be for training. And then once we get in space, we have, I mean, seriously, there's like 10 or 15 people, and that's their job at NASA, is to schedule the crews at the International Space Station. Because not everybody can be at the same place at the same time. We have these important experiments to get done. We have spacewalks to get ready for. We have to do things weeks in advance, and it's a really big, complex puzzle that they put together. And our job as astronauts is to follow that schedule and try not to mess it up, because each one is a delicate work of art. And then physics and the universe comes in and messes up our schedule, and we have to apologize, but sometimes the pieces don't fit and things like that. You have a follow-on. Do I ever forget about gravity? Yeah, I don't like gravity, to be honest. I'd rather be floating around right now. But we saw the demonstration with those goggles where I think it messed up how things were looking at, and you have to adapt. And we humans, we adapt pretty quickly. It's pretty amazing. Now, we might feel a little sick along the way, but once we get over that, we'll adapt to space, it is so much fun just flying around, and you forget about gravity, and you don't need it. And then there's some people, and I'm not like this way, but some of my friends, they come back from space, they have the funniest stories, so I tell their stories. Like, guys, oh yeah, I'm drinking my Diet Coke, and I forgot about gravity, and I just put it out like I would in space, and it falls down, and I make a big mess, right? So that doesn't happen to me, but some people do. They just forget, they're just so used to being without gravity. So it is really amazing to be in zero G. You had the next question.
What made you think of the Iron Man thing?
What made me think of Iron Man thing? Iron Man. No, he's my favorite one, but he's my favorite superhero. I still have Iron Man comic books from back when. So this was it. All my friends on the space shuttle, they hadn't flown in space as much as me, and they didn't know about this, the Japanese experimental module, and then we kind of have like a closet above it. And most of the time in space station, up and down are very arbitrary, but we pretty much have a floor and a ceiling. It's arbitrary, but we feel that way. So we can't really fly too far up because we'll bump our heads. But here we have a whole nother module, quote unquote, above us. And so I showed everybody how to do it. And of course you could just do it like this, but if you put your arm up, then all of a sudden that becomes Iron Man. So when you get to go do that someday, just remember who invented it. It was me, just in case you were wondering. Yes, go ahead. I'm sorry? What is an average day in space like? I will tell you, this is what I like about being aboard the space station and my time aboard the space shuttle, is that there was no average day. I am a person that cannot do the same thing day after day. Tiger Woods, great golfer, I could never do that. I'd get so bored after like 2 or 3 days. Space station, every day is different, and I love it. So one day you're doing a world-class science experiment to help somebody with their PhD thesis, or maybe you'll find some secret to the universe, or next day you're fixing a toilet. Next day you're moving the arm around to the robotic arm to get ready for a spacewalk, which may be the next day. And then you're back to science, and then you're fixing something else. And then next day you have a downlink, which means we get to talk to folks like yourself from space and share the adventure. And I like that. Every day is different. We get Saturdays half off, Sundays full off. I usually sleep in on Sundays, and I read books a lot while I'm up there, and I get a chance to talk to my family, and that's kind of like average time in space, and it goes by fast. 188 days, goes by very, very fast. Yes? What was my worst day? Oh, I did mention in that when I said you'll never give up. All right, you guys want to hear about my worst day? Now, this is kind of personal to me, right? It hit me hard, right? And I hope you guys never have a day like this, but I will tell you my worst day, because it did happen, and it's a true statement. So any of you ever have a birthday? Yeah, probably most of you have had birthdays, right? So it was on my birthday in 1990 where I got kicked, 1991 actually. I got kicked out of pilot training. And that was my path. I said, I'm going to go to these fancy schools. I'm going to study really, 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 really hard. I'm going to do well in school, and then I'm going to go join the Air Force. And in fact, they paid for my undergraduate education, which was good because I have 8 brothers and sisters. We didn't have any money, so it's nice getting funding. And so the Air Force paid for it, so I was going to go I was going to be in the Air Force, go through pilot training. I never failed anything before. So they kicked me out of pilot training on my birthday in 1991, and my girlfriend broke up with me. That was before I was married. And if I had a dog, it would have gotten run over, but I didn't have a dog, so thank you. No dogs were hurt. But I thought my dream would never come true. I could never be a pilot, then I could never be an astronaut, and then I'd have to do something else. And I felt really, really bad. I felt very discouraged. I hope you guys never have a day that bad. But the point is, don't get too discouraged. So I said, all right, I felt bad for a while. Don't tell anybody. There might have been crying involved. I don't know. I don't remember. But it's okay to feel bad. It's okay to have a bad day. It's okay to cry if that's like who you are. All right? It happens. But you can't stay there forever. You got to pick yourself up. And it was really, really hard. But I got back up and I said, well, there's other astronauts that aren't test pilots. What else could you do? He said, well, you could be a flight test engineer. You're like an engineer who flies and tests. And I said, well, I'm a good engineer, just not fantastic at flying. So I said, so I looked ahead, what other astronauts, how other people got to become astronauts. And I said, well, I can't follow my plan A, but I can do this other path. There might be other ways. And so I became less discouraged, and then Air Force sent me off to do something else, and along the way they said, hey, you're pretty good at engineering, you should go to be a flight test engineer. So I went to test pilot school, and then I graduated at the top of my class because I was very motivated by that point, and 2 years later I became an astronaut. So the point is, and the funny part, the irony part, is that I became an astronaut 5 years faster than had I been a test pilot route. So it actually worked out to my benefit. I became, and I got to fly in space sooner than my colleagues who were at the top pilot training at the same time. So the point is, we're all going to have bad days. They're going to stink. I was thinking of other words to say, but I'll say stink. And it's not going to be fun. And but I talked to my friends. Can you imagine calling my dad, hey, Dad, I got kicked out of pilot training? He would, I didn't want to tell him because he would have been sadder than I was. But anyway, things go on, and you pick yourself up, and you figure out other ways to have your dreams come true, because they can happen. Yes, ma'am. Have you ever lost track of time when you're in space? Is that the question? Yeah. So it's really weird, right? We showed that thing about flying around the Earth at the dark time. We go around the Earth, every 16 times, 24-hour period, 16 times a day. We are built as humans to pay attention to the lighting conditions around us. So when it's light, we tend to be awake. I know you guys are, some of you teenagers, right? You sleep, your sleep pattern's a little different, but in general, people go to sleep at night and wake up during the day. And if you did that in space, with all the lighting patterns, it could really mess you up. Sleep, wake, sleep, wake. So it's really easy to lose time in the space station because you can't really pay attention to the lighting outside of you. Like we learned about this when we lived underground in caves because there was no light. We just, we stayed on the European Standard Time. It was in Europe, the caves that we were living in, but we could have easily switched because it was always perpetually dark inside the cave. And so without those external sources, without paying attention to calendars and schedules, we could easily lose track of time. All right, yes, please. What's it like going on a spacewalk? It is the coolest, scariest thing I've ever done, and I've done 9 of them. So when I got to NASA in 1996, they said, hey, welcome all you new people. We're really glad you're here. If you are not 6'4" or taller and have, 8-foot long arms, you will never walk in space because we only take very tall astronauts to walk in space. And I'm there, oh man, I just got here. They told me I can't do a spacewalk. Guess what? World keeps changing, right? So luck favors the prepared. So I did get a chance to go on a spacewalk, first with the Russians, actually 6 spacewalks with the Russians. No other American has a chance to do that. And the reason why I did, because I could talk. They like it when, people like it when you can speak their language. And turns out I could speak the language. So they trusted me, went outside for spacewalks, and then 3 American spacewalks, going to be doing some on my next mission. Looking forward to it. It is scary. It's hard work. You're fighting against the suit. The suit's pressurized. It's full of oxygen and only oxygen, so it's very dry. You have to drink a little bit of water. We have a little drink bag in there. Drink a little bit of water just to be able to talk and say, "You're all Roger, Houston." That takes a lot of work. You move around like this. Every time you squeeze it, your hands get tired, and you have to do that for 6 to 8 hours. But you go outside and you see all of creation. You see the Earth below you at 17,500 miles an hour. Did you guys ever see these Roadrunner cartoons from the old day where that coyote was chasing that Roadrunner? And that coyote would be like, he'd run off a cliff and he'd be there, hey, yeah, what's going on? And he'd look down and then he'd fall down. And it was always like a little cloud of dust at the end. That's how I felt on my first spacewalk. I'm hanging on the space station and I look down. It's like, oh man, that's a long fall. It's like 250 miles down. And they're, man, what kind of cloud of dust would that be? But turns out I was weightless, so if I would have let go, I would have just not fallen down. But it was still, my mind was thinking about it. So it is kind of scary. But then you look outside and you see all of the stars. They are right out there. And there's nothing between you and the rest of the universe except your helmet visor. And that is just something really special. And I'll tell you, I'm going to share this a little bit with you just for a second, is that we have that whole universe to go explore together. And I'm not quite sure why we're fighting down here on planet Earth. Like Mike Hennessy said earlier, hey, we got to take care of planet Earth. There's a lot of it's an amazing place. But we got the whole universe to go explore together. And that's why we need your help. We really need people to help us to build things, make things, to be inspired to go fly beyond planet Earth, because there is such a beautiful universe out there. And that's for us to go explore. Yes? How long did it take me to get used to Earth gravity again? Yeah, so everybody is different. Individual results may vary. So my first mission, 188 days in space, we landed, and for about 15 minutes, I was feeling a little sick to my stomach, a little woozy, but then I stood up and started walking around, and it was like I was wearing those goggles. It was a little bit wobbly, but then just half an hour later, I was kind of back, and I felt so good. It was surprising, right? This is just me. Some people, it takes them a few days to not feel bad. I felt good pretty much right away. But I played a trick on our flight docs. I said, hey, look over there. And they looked over there, and I started running. And they were like, don't run, don't run. It's like, no, but I feel so good. So I was really glad to be back on planet Earth. So everybody, it does take us a while to get adapted. We think we feel fine, but then we still don't have a good sense of balance. Our muscle mass and our bone mass is definitely reduced from space, even with our exercise. So we go through a physical rehabilitation for about 6 weeks when we come back, and then usually we're back to 100%, if not more than before we left. They won't let us drive for a week because they think we're going to be a little bit off balance, and they're probably right. So it's great. They give us a driver and drives us around. It's kind of boring, but it's kind of fun. Yes, sir. Yep. On Arthur, yeah, I was on an episode of Arthur, yeah. So you guys know Arthur? You guys know the Wiggles, or is that too old for you? Yeah. Yeah, so no, it was really fun. Once you fly in space, people want to pay attention to you or something. So anyway, it was really cool because I like Arthur. He's like an aardvark. They made me to a bear-looking figure. But it was really cool. What I liked about Arthur, I'm going to bring that up while we're talking. What I liked about Arthur was we started at the beginning, and they said, hey, we want to tell a story. Do you have any cool space stories to tell? And I said, I don't know, they're all cool. So none of them are cool, I don't know. And they said, well, tell us something about what happened to you. Well, on my very first spacewalk, we had a problem with my oxygen valve, and I started leaking all my oxygen. It wasn't my fault, wasn't the engineer's fault, it was just something that happened. And then it was a little bit scary because I was gonna run out of oxygen. You guys probably all like oxygen too. You were pretty much all addicted to breathing. And so we had to get back inside the spacecraft, and it was back in the space station. Oh, there it was. And there's Arthur. Yeah, that's exactly what I look like, right? We had to go back inside the space station, and we were really disappointed. So we made an Arthur story around that, and that whole creative process of, what character does what and what happened, and we started that episode by talking about launching model rockets, because I had that experience right here at CCAC of launching model rockets, and so we talked about a model rocket, and the kids couldn't build it. Then they started fighting each other, and they learned to work together as a team. They had a bad day where their parachute blew away, so they had to think of a different way. And I think they used a coffee filter from a drip coffee pot. So it was kind of fun to be a character, but it was really fun to create a whole episode, to tell a story that might inspire other people, to tell a story about not giving up when you think you have a bad day, to tell a story of, hey, we're all humans, we're going to fight each other sometimes, but we're going to work together at the end. And that's what I liked about that episode, and it came out really nice, and I'm very proud of that. Thank you for that question. Yes? Yeah, this is a really good question. So, the question is, so you saw that that ball of water, right? Yeah, that when you put water in space, it just kind of sticks to itself. That's surface tension, and there's no gravity to bring it to the ground or anything. So surface tension makes water want to stick to itself. And then the question is that what happens inside your body? Yes and no. So, for example, if we drink something in space, we drink water or anything, water likes to stick to itself, but it also likes to stick to other things, right? So it actually sticks to our insides. It sticks to our the tube, the food tube that goes down to your stomach. And in your stomach it can turn into blobs like that, but it also coats the outside of your stomach. And these are really good questions, because when we first started sending people into space in the 1960s, we did not give them, we weren't sure that they were going to be able to eat or drink, so we sent up our chimpanzee friends, and they seemed to do okay, so we sent up some chimpanzee Navy guys. We sent up some astronauts, and they got a chance to eat in space, but they had to drink. They didn't eat real food. One of the astronauts got snuck aboard a ham sandwich, and they got yelled at because that hurt somebody's experiment. But it turns out we can eat and drink normally, and the other part of digestion also works normally. It just takes your body a day or two to get used to it. All right, we have time for 1.5 more questions. 2 questions. Yes. Yes, the question was about my patches. So this is kind of my special flight suit that I wear. I usually don't wear it around the office. I usually don't wear it when I fly. We wear these when we fly our T-38 airplanes. It's made out of Nomex, which is a fire retardant kind of thing. But we asked about my patches. And so each mission that I flew on, we made patches. I think that's sometimes a team building exercise. When you join a new team, they say, hey, make your own space patch. So we make our own space patches. So my first 2 patches on my arm here were from my first mission. So it was the Soyuz up and down, including with Andre Kalpers. He didn't stay with us, and then it was just me and Gennady on Expedition 9. A few years later with the black and gold, because I was commander, I got to choose the pictures. Can you guess why I took black and gold on my patch? Yeah, I don't know why. But anyway, black and gold, and then to the 18th expedition. But we also flew up on the 100th Soyuz flight ever, so we made a patch about that. And then this was my space shuttle patch that we flew on STS-130 for 18 days to the space station. There's a lot of symbolism in our patches, a lot of things that mean something. I think on Expedition 18, all of the symbols here have something to do, the stars are all for each one of our children, that kind of thing. So we put in, secret little symbols in there that mean something to us, that helps motivate us and keeps us together as a team. So we have time for one last question. Yes, ma'am. I was going to totally choose you. You're the chosen one.
No, I know that you have like the little like bed compartments, but like, do you have to strap yourselves down? And if you don't, if it's like not exactly required, is there like a favorite way you have to sleep in?
Yeah, sleeping in space, right? It is a fun thing to do, but it's also really important because every day is a different day, and we need to be up and ready for it. So sleeping in space. She mentioned, we do have a sleeping compartment, and I will tell you that actually, I'll just leave that one up. I will tell you that I grew up with 8 brothers and sisters. I never had my own room until college. So I was loving having my own room in space. It's like, I got my own room. It is a really small room. And since the microgravity is such that you don't know if you're upside down or right side up. So they actually put us in a vertical position, but once you close your eyes, you can't tell. So we actually sleep standing up. They give us a sleeping bag because some people like to have that. Me, I run warm, so I really don't like a lot of blankets or covers, but my sleeping bag was good, and we strapped the sleeping bag to the wall of our crew quarters, and then we have like a laptop in front of us that we can use to call our families or read books or something, and so that's a sleeping station. And again, I got my own room, yay. We could sleep upside down if we wanted to. We could sleep in the corridor just floating around. After a spacewalk, don't tell anybody this is one of those other stories. I fell asleep while we're just eating and drinking a little bit of tea and cookies. Russians like to do that. So after a Russian spacewalk, I fell asleep because the spacewalk was really hard, and I was just tired. And then when I woke up, my head was down, floating upside down. I was floating upside down, and my friends had moved me to the toilet area, and my head was not in the toilet, but it was floating above the toilet, and they said, "That's what you get for falling asleep on us." I thought it was funny. So it's good to strap yourself down and not find yourself floating around, because your friends might play a prank on you. So, ladies and gentlemen, boys and girls, we got a lot for you to do today. I know you're teenagers or almost teenagers or over teenagers, and you got lots of things to think about what to do with your future and all that kind of scary stuff. It's intense. But today, just take some food for thought. Study what we're trying to share with you today. Think about it, because the more things you know, the more opportunities you have. And the more opportunities you have, more cool things that you can do with your life and have fun along the way. So as a part of the team that wants you to be successful, as part of the team that wants you to have that special feeling of when your dreams are coming true, I'd like to say thank you for your attention, thank you for your kindness, thank you for your questions, and be good, study hard, dream big, never give up, and ask for and give help. Thank you very much.
Requirement for you to participate. So any of our CCAC students, if they have a good idea, they can pitch an experiment to go to space, they can write it up, and they present it in a competition where judges from Astrobotic, NASA astronauts, other space leaders will evaluate the proposals. So it is super cool. And the first year we did it was 2021, and COVID and stuff meant the experiment didn't go into space until recently. But these are two of our students, two of our amazing students who designed an experiment where they said, hey, you know what's kind of interesting is more and more people are doing space tourism now, right? You get astronauts like Astronaut Fincke who do the hard work, like NASA, but then you get people who want to spend like a couple $1 million and go up on a Bezos rocket, right? Kind of fun to maybe blast off into space and have a good time. What consequence does that have on your body? So they designed an experiment where they launched some cancer cells up into space that were dormant, and they wanted to see if going to space would wake up those cancer cells, right? Really good experiment, because I would like to know if I have dormant cancer cells in me, I go up to space, will it wake them up, right? Super cool idea. But along with that idea that our students design an experiment, you know, Astronaut Fincke spoke and this is so cool. So it went up last October, and
a tangle of tentacles, strangling family budgets. Corporations raising prices 5 times faster.
But it's amazing. So they went up, it was a nightly...
T-minus 5, 4, 3, 2, 1, ignition, liftoff. Vehicle is pitching downrange.
See it, right? The students got to see the launch.
Engine chamber pressure is nominal.
Go toward Kennedy Space. Just amazing that it happened. So, I mean, you can see it's still going off into space. Even down, it was absolutely beautiful. But something that goes along with those experiments are the idea that there are mission patches that accompany every mission that goes into space. And Astronaut Fincke talked about this, how those patches have symbolism and they're meaningful. And some of the symbolism is about like what's going on the space mission, but some of it is just very personal to the astronauts. And it does a lot of stuff. And NASA has done it ever since the first mission. So this was, if you look closely at Astronaut Fincke flight suit, you can see this patch is on there from his space shuttle mission. And there's some historical patches from the Apollo and earlier missions that I put on here. This is a Soyuz mission, I think. But really, really cool. So what we did is we wanted to do this too. So we held a patch design competition where anyone who wasn't in CCAC, they were high school students and people around the region, could compete to design a patch that would accompany our student experiment to space. And we had more than 200 students submit patch designs. And so I want to actually take a second and recognize the winners of the patch competition from Mission 17. These two individuals designed patches that went up into space along with our student experiment, and we got the patches back from NASA, so we want to present to them, some pretty cool stuff that actually flew into space. Out of all the students that participated, both winners came from Parkway West Career and Technology Center. So I'd like to recognize Joey Clark and Angelina Kness. Can you guys come up here? And teacher Betsy too. Yeah, can you guys come up? So we want to present them with their patches all framed up real nice. Both patches are in one frame, so you guys can fight over exactly who gets to take it home, or maybe it goes to school, I don't know. But we're really proud of you guys, great work. Let's do a picture and give this to y'all, because it's a big deal. Maybe, you guys hold it? Yeah, you guys. There you go. Ready? Awesome. Thanks, guys. Congratulations to Angelina and Joey again. Yeah, and they're going to try and make sure it survives the bus ride back. So super cool. Sneak peek, we did the patch competition again for Mission 18, and 2 students from Parkway also won that. Joey, again, a 2-timer, and Reagan. But watch the news, right? Because that next CCAC mission is going to go to space this fall. Launch dates always change because there are things going on like weather and readiness, but right now that launch is scheduled for October 30th, 2024. NASA uses this terminology NET, which means no earlier than, but watch for that. We'll try and put a release out there so you guys can follow the progress. But if you're thinking, what do I want to do when I finish high school? Consider coming to CCAC, take some classes with us. If you want to design an experiment that will go into space, you can absolutely do it. It's open to each and every one of you. And so I'm going to turn things back over to our provost, Dr. Steve Wells, who's going to tell you guys what's coming next, where you'll meet some CCAC faculty, some of whom actually mentored teams that participated in this process, and see some of our equipment on campus. So thank you guys so much.
So yeah, then they send up the guy in the suit to give you directions. I was talking with Astronaut Mike. I think we might have possibly been in the same class at the Buell Science Center when we made model rockets, although I think mine was a different rocket, so probably a different time. Mine failed spectacularly. I didn't put the wadding in right, and the parachute fused. It was plastic, and so it crashed to Earth unceremoniously, but it was a lot of fun. The other thing that I was thinking about while he was talking was about failure. Hopefully you'll never fail, but chances are you will at some point. And what's important is what you do after that. I told you I failed out of college once. It's not the only time I've failed in my life. But you take that next step forward and you walk through the door that life opens for you. There's always something to go to. Thanks, Dr. Starr. Thanks, Mike Hennessy from the Moonshot Museum. And thanks to NASA astronaut Mike Fincke. And thank you all for being here today and being part of this. And thanks very much for all the people who made this possible. There was a whole team of people that planned all this out and got you in your seats and got this presentation in front of you. So now I have some instructions to guide you through the next steps in today's event. Students will move in groups to activities in this building and in the Center for Education, Innovation, and Training, which is next door. We've got some fun demonstrations and activities involving microgravity, robotics, and astronomy. Representatives from the Carnegie Science Center are here too, so you'll get to do some activities with them. As a reminder, don't forget to fill out raffle tickets. If yours have not been collected yet, there will be a place out in the lobby where you can drop that off before you leave today. Also, before you leave today, you'll be able to pick up gift bags and box lunches, but you'll be guided through all of this. There were a couple schools that didn't get pictures taken with Astronaut Mike. And so if, as I send you out with your guide, your school was one of those that didn't get a picture taken, make sure that you tell your guide, and we'll make some arrangement to allow all the school groups to get their pictures taken with the astronaut. So I don't want anybody to feel left out. Make sure you speak up. Schools are going to exit with a CCAC guide. When I call your group, please stand up and exit with your guide, who will take you to the activity locations. And thanks again for being here and for being such a great group of students. Really appreciate it.